In this video, we're going to talk about radical expressions and radical functions. A radical is another word for a type of root. It could be a square root, a cube root. There are many others, a fourth root, a fifth root, and so on. So I want to start by giving a definition, and then we'll develop some of the properties or rules that govern how square roots and cube roots work. And then we're just going to kind of go over all of the basic things that relate to radicals. So let's start with the square root. I love this definition. So a square root is one of two equal factors. The word factor here implies multiplying. So if I can take a number like 25 and divide it up or break it up into two numbers that are multiplied, two equal factors, the square root will take one of those two equal factors. And so we know the square root of 25 is 5. It works the same way for a cube root. We usually write a cube root with a little 3 out front, and this shows that we're taking one of 3 equal factors. 8 works nicely for this because I can break 8 into 2 times 2 times 2. There are 3 2's there, so the cube root takes one of 3 equal factors. Okay, it would work the same way for a fourth root, fifth root, and so on. So I can really have any number of factors, and the nth root would work in the same way, kind of follow that same pattern. I like to use this just to talk about some of the terminology that could come along with a radical. So if I want to be general and talk about the nth root of a, we could take a look at each of these pieces. The square root symbol is usually called the radical. The number on the inside of the radical is sometimes called the radicand, but usually I see it called the argument more than I see the word radicand. The argument is kind of a more general term that just means that this is what we're applying the operation to. I'm applying this root to this argument. Then the n is the little number in front of the radical, and that's called the index. So for a cube root, that little number is a 3. So you might see the word index. You might see all of these words sprinkled throughout this chapter, so I always like to bring them up just so that you know what they mean and stand for. Okay, so now let's take a look at some of the rules or properties for square roots and cube roots. The first one is a square root. Really, we're going to say square root, but really we mean any even root can only operate on a positive number. So I can't take the square root of -4. The reason is, just like we were just talking about, I can't break up -4 into two equal parts that are multiplied. The best that I can do would be to break it into -2 and +2, but these aren't equal. So the square root cannot really do its job. It doesn't see the two equal factors, so it can't take one of two equal factors. And we can't break up this negative into parts. Eventually we'll talk about complex numbers and we'll use an I here, but for the moment we're going to say that this is undefined. And you could check this with your calculator, right? You could try to take the square root of something that's negative, like -4, and it would also give you an error. Okay, the second property says that using a square root, or any even root, to solve an equation produces two roots. So we're going to be looking at equations later on in this chapter in much more detail, but for now, let me just give you a quick example. If I had an equation like x squared equals 25, there's really two solutions to this equation. So to solve, one way to solve is to take the square root of both sides. And again, we'll say this many more times in other videos, but anytime I put the square root into the equation, I need to include a plus or minus. On this side, the square root and the square are going to cancel each other out. And I know the square root of 25 is 5. So I get plus or minus 5, and this tells us really that we have two solutions. X could be 5. Think about plugging that in. 5 squared is 25. Or X could be negative 5. Because negative 5 squared, negative 5 times negative 5 would become a positive 25. So these two roots, one of them being a positive root, one of them being a negative root, right? And those are going to show up anytime we're solving an equation, mostly because we want to get all the possible solutions. Okay, the third property says that the radical symbol for any even root, we're going to talk specifically about a square root right now, this represents what's called the principal root. So if I were to just come up to you in conversation, let's say, and I asked you, what is the square root of 25? Usually we just say 5. So that's kind of customary, and that's called the principal root. So we don't usually say both 5 and negative 5, we usually just say 5. So if the square root is already in the problem, with no extra things in front of it, it's assumed to be the positive root. Okay, before we leave that, let me just make sure, because I didn't really say this at the beginning. When we say even root, we mean any root where the number out front is even, right? A square root falls into that category because even though we never write it, technically there's a little 2 out there. Remember, we just said it was one of 2 equal factors. But it could be any even number to be an even root. So it could be a 4th root, a 6th root, and so on, right? All of those would count as even roots. So the index would be even. Okay, the last property that we're going to look at deals with odd roots. So this one says odd roots maintain their sign, and so we end up with only one root. So, and if I'm taking a number and I'm breaking it into an odd number of factors, like a cube root, I'm breaking it into 3 factors. We've already talked about the cube root of 8 being 2, because I can break 8 into 3 equal factors of 2. A cube root will work for a negative number, right? This kind of the opposite of the first property we just talked about. I can take negative 8. Because of the way negatives and positives work, when I multiply them, I can break it into 3 negative pieces, because a negative times a negative times a negative is going to give me a negative result. And so because these are all equal, I can do this. I can take one of 3 equal factors, and this becomes negative 2. So for a cube root, if I start with a negative inside as my argument, I'm going to get a negative result. If I start with a positive number as my argument, I'm going to get a positive result. And notice I don't have a plus or minus here, right? I don't have to worry about that because I'm going to keep the same sign I started with. Okay, and we could say something similar for odd roots, right? So these would be any root with an odd number out front. We're talking right now about a cube root, but it could also be a 5th root, a 7th root, and so forth. Okay, so let me give you a few quick examples to try based on what we just talked about. So take a second if you want. You can even pause the video and try these few examples real quick. See if you can fill them in. I'll give you a quick second. Okay, a lot of these you can do in your head. The square root of 49, I think you know that one. That's 7. The square root of negative 49, this is the one that I can't do right now. So for now, I'm going to say undefined. Eventually, we're going to talk about complex numbers and we'll say 7i, but for now, I'm going to say undefined. Negative square root of 49, if the negative is on the outside, I take the square root first and then I apply the negative. So negative 7. The cube root of 27. 27 is the same as 3 times 3 times 3. So the cube root of 27 would be 3. The cube root of negative 64. It turns out 64 is 4 times 4 times 4. Since it's negative, we can make each of those a negative 4. Notice I started with a negative, so I'm going to get a negative result. Okay, and then I always put this one in here because they won't always be perfect squares and perfect cubes that we can calculate in our head. I can't really calculate this in my head, but I can definitely put it into my calculator. So we can take the square root or the cube root, say, of a number that's not going to come out nice and even. So if you put this into your calculator, you get something like 2.236 something, 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 right? So it is possible. Okay. I think next we're going to take a look at fraction exponents. So another way to represent a root is to use a fraction exponent. And the fraction exponent that we see does correspond really closely to the definitions that we were just talking about. So when I use, instead of a square root, I can represent it as a fraction exponent where I have a fraction of 1/2. You can think of this 1/2 as one of two equal factors, right? 1 out of 2. And so that's kind of where that comes from. We also talked about, even though we don't usually write it, there is a little 2 right here out front. So you could kind of track it that way, kind of let that 2 represent the root that we're using. The same thing would be true for a cube root, right? So I can use a cube root or I can use a fraction exponent of 1/3. And you can think about it the same way. This is one of 3 equal factors. And so that is very much based on that definition. We can also use this fraction exponent to represent both a power and a root. So when I do that, the top of that fraction is going to represent the power, the exponent that's being applied, and the bottom of the fraction is going to represent the root that's being applied. And the fraction exponent is kind of a condensed way to show both at the same time. So there's a couple of ways we can write this. We'll be really general here and say m over n. So the m is in the top of the fraction, that's going to be a power, so let's say a to the m. And then I apply the nth root. The bottom of that fraction is a root. Okay, I actually am able to apply these in either order. So this time I applied the power first and then I applied the root. But I could do it in the opposite order if I wanted to. So that's kind of what I've drawn out over here. So it's the same exponent, m over n. This time I applied the root first. So I took the nth root of a. And then I applied the power on the outside. These two things are the same. They're equal. They're just two different ways that we can write it. Okay, and It's been a while since we've talked about exponent rules, but all of the fraction exponents also obey all of those rules that we've talked about at the very beginning of the semester. So let me give you a few examples so you can see how they work. Let's see, we'll do it like this. These are a couple examples from your book. Let's say we have -8 raised to the 2/3 power. Again, we can do these in any order we want. So I'm going to choose one just because I don't want to do the same example a lot of different ways. But really we could either apply the root or we could apply the power first. It doesn't really matter. This time, because -8 is a perfect cube, I'm going to apply the root first. And then I'm going to apply the power. For this problem, it's very equivalent. So we could have gone the other way. We could have done the power first, and it really wouldn't be any more or less work, to be honest. Okay, and now that we've kind of translated that, right, we can go ahead and evaluate. So I can take the cube root of -8. We've done this several times now, so that's -2. And then I can square that. -2 times -2 would give me +4. Keeping in mind, and I kind of took this off the screen, so I'm going to write it down again right here, is the power on the top over the root. Okay, so let's take a look at this one. This one's a little bit different, and the font is not perfect here, but this is a negative fraction, right? So I have 16 raised to the -3/4. Do you remember what a negative exponent does? Remember, it creates a reciprocal, or it kind of flips things around the fraction bar. So if I think of this whole thing as over 1, the negative exponent is going to move this 16 down to the bottom. And since I've moved everything down to the bottom, I'll have just a 1 up there. So that takes care of the negative. Once I move it, the negative goes away. And then now I can translate it just like I did in the previous example, right? What kind of root is going to be applied here? Yeah, it's a 4th root. And a power of 3. I chose to do it this way because I can take the 4th root of 16 really easily, but 16 raised to the power 3, I'd have to pull out my calculator for that. So I know 16, I'm going to do this off to the side, is 4 times 4, and each of those 4s is 2 times 2. So the 4th root takes one of 4 equal factors. So the 4th root of 16 is 2. Oops, sorry, I lost my 1 over. So I got 1 over 2 cubed, or 1/8. All right, I'm going to add in this idea next. So the power and the root, if they match, are opposite operations and they cancel each other out. So there's lots of ways to think about that. You could use the fraction exponent actually to think about that. Or you could just think about them canceling. Okay, I think you can, these are pretty intuitive. So the cube root of 4 cubed, the cube root and the cube are going to cancel each other out. Okay, if that's not something you can just kind of accept, you could think of it as, remember we just said that the cube root is the same as an exponent of 1/3. And so when I raise one exponent raised to another, I multiply. And 3 times 1/3 is 3 divided by 3, or just 1. So really this ends up being 4 to the power 1, or just 4. Right? So the cube and the cube root, they canceled each other out. And this is one way to see that. Same thing would be true here. Right? The cube and the cube root are going to cancel each other out. The cool thing that happens for odd roots, right? If I start with a negative, I'm going to end with a negative. So even if I didn't cancel them, if I worked this out, negative 5 cubed would be negative 125. And when I took the cube root of this negative, I would get negative 5. Just like you would have guessed. Okay, same thing's true for a square root. So the square root of 15 squared, the square and the square root are going to cancel each other out. Okay, if you didn't believe that that was happening, right, you could work it out in a couple of different ways. We've done it 2 ways so far. You could try 15 times 15 is 225, and when I take the square root, I just get 15. So they cancel each other out. This is the one exception to that rule. When I take the square root, remember I can only take the square root of something positive, and when I do that, the result is something positive. So I'll take the square root, negative 5 squared gives me positive 25, so I am able to take the square root, but I don't get negative 5, I get positive 5. So this is the one that's a little bit different. So we do have to watch out for that. Right? If I can't take a square root and get a negative result. And so they are opposites. They do cancel each other out, but I lose my sign. Okay, just a couple of more quick examples using the idea of fraction exponents. So I wanted to give you a few that bring in those properties of exponents again. So usually the directions say something like rewrite with fraction exponents and then simplify. Okay, so I think these first 2 on the left here kind of follow those directions. And then these 2 are really just more simplifying than anything else. So if I rewrite this with a fraction exponent, remember the top is a power and the bottom is a root. So the power here is 5 and the root is a 3. Same thing on the bottom. The power is a 2 and the root is a 3. And then to simplify, we want to use properties of exponents. If I'm dividing with the same base, I'm going to subtract the exponents. And when I subtract 5/3 minus 2/3, it's going to give me 3/3. But 3 divided by 3 is just 1. So my final answer would be x to the first, or just x. Okay. Let's try this one down here on the bottom left. This one always looks a little crazy at first, so we're just going to take it one step at a time. We have the square root of the cube root of x. So let's kind of work from the inside out. So we're going to leave the square root for now. We're going to rewrite the cube root as a fraction exponent. So from the very beginning we said a cube root was one of 3 equal factors, so we could use that idea. If you want to track where the power and the root are coming from, you could pencil in a power of 1. That's okay to do. So I'm going to have the power of 1 over the root of 3. And then the square root, we said, even though we don't usually write the little 2 out front, you can think of there being a 2 here, and that's the root. So we have 1 over 2 for the square root. If I raise one exponent raised to another exponent, Remember that property, it says that we multiply. So we'll multiply 1/3 times 1/2 to get 1/6. Okay, if you wanted to write it as a root, I'll just add this in for bonus. This would be the same as the 6th root of x. So it turns out if I have more than one root, remember the square root has a little 2 here, I can multiply the index numbers and then combine them all into one root. That's something that I didn't really understand for a long time, and if that doesn't make a lot of sense to you, that's okay. This is really what we're working on right now, but it's kind of an interesting fact if you are able to receive that. Okay, this one in the upper right is actually very much the same. The first few steps are already done for us, so it's written already like fraction exponent. And here's another scenario where we're raising one power to another. So the properties of exponents tell us that we're going to multiply 3/5 times 2/3. You can multiply and then reduce, or you could cancel out these 3's right away if you want. That's going to end up giving us x to the 2/5 power. And that's really as simple as we can do. We're not asked to turn it back into a radical, so we'll just leave it just like that. There's one more down here at the bottom that usually you have something like this on your homework, so I always try to do one of these in class for you to make sure that you understand it. Really, we're kind of combining a couple of examples that we've just done into one. So the top and the bottom both have one exponent raised to a second exponent. So I'm going to be multiplying those. 3 times -1/2 is going to give me -3/2. And 1/4 times 2, I'll write it off to the side right here, would give me 2/4, which I can then reduce to be 1/2. Okay, the numerator has a negative exponent, which means that it's going to be brought down into the denominator. And since I'm bringing everything down in the bottom, I'm going to have a 1 left in the top. And then I would like to combine these k's all together into one. So what do I need to do with the exponents? I need to add them. So 1/2 plus 3/2 would be 4/2. The 4/2 would be 2. So I get 1/k². All right, well, I hope this gave you a good introduction to radicals, kind of a look at the basic rules, and then also kind of diving a little deeper into fraction exponents and working with fraction exponents. I hope you'll take some time to practice, and we'll see you in the next video.